Hi, everybody. Um, I would like to talk about a little side project I was working on, and it's called Rusticl. I was talking about it on last XDC. It's basically an OpenGL implementation inside Gallium, um, written in Rust. So, what's kind of the state of OpenCL and Mesa before Rusticl got merged, and there was this front end. It was called Clover, or how it is pronounced, I don't know. Anyway, it was accepted in 2012 inside Mesa, so it's a little more than 10 years ago. It's written in C++, and at the time before I started to work on OpenCL and everything, it was targeting LLVM directly. So there was nothing in between. It fetched from the driver what target LLVM should use, and it was just spewing out the LLVM IR fitting to the driver. So later on, I added to support for Near because I was thinking, okay, OpenCL and other drivers might be something people want to have. And I wanted to get it to work for Novo anyway, so that's why I was starting to work on it. There's currently still some development happening on it. It's, I think, roughly 60 patches a year. A lot of those are still like, oh yeah, it doesn't compile with this version of LLVM, or somebody renamed some fields in Gallium, so that's most of the work happening at the moment. And I was, adding support for images for Near, with Near, and then Near support as well. So that's what happened recently. There are also some differences between, all the OpenGL stuff we are doing and Clover, which makes it harder or more annoying for drivers to actually use. One is this IR near serialized thing, which is a result of the discussion we had upstream, where I was saying, okay, I just want to use the near, but that doesn't work because Clover is also using the dynamic pipe loader, and you just can't, pass the pointer around. So in order for drivers to accept this, you actually have to serialize the near and then deserialize it in the driver again, which comes with overhead and stalls a little bit. So that's not perfect. I also tried to actually move to the static pipe loader, but maintainers didn't like it. It's even the only user. So if we could say, okay, we get rid of anything using the dynamic pipe loader, and Clover is the last thing, we could drop this piece of code as well. There are also like some weird differences on local, like in CL it's called local memory, in Near we call it shared memory. It's used different in Clover than by the rest of Mesa, which usually ends up drivers over allocating shared memory, which is not great. And it also has this pipegrid info input pointer thing, which is essentially just, it's exactly like GL uniform memory. It has no difference. It has always been there, and nobody moved it over to just have it in const buffer. So in the end, it has not a lot of users. It basically only works on R600, I think. Somebody said images support is broken in Radeon SI, and nobody noticed. And generally, it doesn't seem like a lot of people actually care about it. So I thought this had to change. So what was actually my main motivation in working on Rusticl? We actually have at Red Hat this days of learning where I was thinking, okay, we can spend a whole day just, doing random stuff. And I thought, okay, maybe pick up Rust and see how it goes. So I've been kept doing it and was thinking, okay, yeah, Rust is actually a nice language. Let's see if we can actually make it, use it inside Mesa. So Is it feasible? And also more importantly, is it actually sustainable? So if people are now, writing merge requests and they're changing Gallium interfaces, I also touch in Rusticl, they actually have to change Rust code. I think today was the first time actually somebody, asked me on how to fix some stuff. So I was kind of worried because it was like, nobody really asked a lot about this. So maybe it just isn't a big problem at the moment. So let's see how it goes in the future. So the other question is, can we just take some random C API and implement it in Rust? OpenCL really is like OpenGL. You just have C headers and an API you have to provide to the application. Then, because most of Mesa and also the OpenCL headers are all in C, what are the problematic things when you actually generate Rust bindings for this C code? And the other big thing is that there are still people really interested in OpenCL. So this just comes up. I think somebody said in the Radio and IRC channel every week somebody asks about this. So okay, but why actually using Rust? And the first rule or the first thing here is kind of basic thing on how Rust actually works. So if the compiler shouts at you for doing stuff wrong, even if you say, oh yeah, but I've been doing it in C my whole time, at the whole time this way, then no, it's wrong. So, and most of it comes from, you're referencing stack memory or stuff like this. And in C, it's just, 1 in 100 chance it actually breaks and you never noticed. But in Rust, a lot of this stuff is actually caught at compile time. So after you just accepted your fate and let the compiler shout at you, it makes things a lot easier because you're not spending time debugging random memory problems. And by design, you also have to think about how you're actually doing threading and memory safety. So what I really like the most, I think, is currently how threading is done in Rust. You basically can just capture closures and pass things around and basically just works. So I think I never saw a threading API which was this amount of joy. Anyway, so Rusticl, it was actually merged last month. So this is great. It's a full OpenCL 3.0 implementation, at least, all the required features and everything. It's entirely Spurvy and Near based, and I'm not planning to add support for LLVM backends. So this is not going to happen. Also, what I decided from the start that it has to be as close as possible to whatever we do for OpenGL, because otherwise drivers probably won't care as much. It also has quite a low API overhead because everything which actually touches, for example, pipe context, is done in a worker thread. So you really just, what usually happens is you have the overhead of the OpenCL validation, and that's essentially it. Images are fully supported, and I got it to be passing the OpenCL conformance test on my Intel 12th Gen GPU and also on Radeon SI. Okay. So, but how does this all, integrate it on the build system level? A lot of projects actually mixing up C and Rust usually just invoke cargo directly in their build system, which has a few drawbacks because you actually have to synchronize, when did something change on the C side, when do I actually have to recompile things on the Rust side. And we actually have proper Rust support in Mesa now. At the start it had a few bugs, but I figured it out with Dylan. And the only drawback, or the real drawback we have, is we don't support third-party crates. So all the Rust code I've written, it's just using the normal standard library Rust provides. So which drivers are actually supported? At the moment, Iris are supported and LLVM pipe, so they should just work as long as you enable OpenCL. I think Panthers is also pretty close on just passing all the tests, but I'm not sure if it passes all the tests. For DNSI, I have a work in progress branch somewhere because there are some questions, some questionable changes I've made, and I have to clean it up. Nouveau also basically works, but there I usually have to fight with GPU crashes and all this kind of stuff. So I got sidetracked and yeah, have to figure those out at some point. And the only questions I really have left to actually say, like, okay, this driver supports OpenCL, can be enabled by default, and I'm not quite sure what we actually want to enforce there. There are some problems, but I will go into it later. So, what actually runs with OpenCL and Rusticl? And I've been testing a lot with Darktable. Darktable is a photo editing tool which has roughly, I think, 300 OpenCL kernels. And as far as I can tell, every filter actually runs in OpenCL if you enable it. So this is a quite good tool to test. Does it actually works? And it seems to be all right. There's still this kind of problem where sometimes the overhead of using an OpenCL device is still higher than just doing CPU rendering. So especially if you use LLVM pipe, you'd notice that using OpenCL is just slower. But for Iris, I think it's kind of the same. And besides that, I suspect that most applications will probably just work. I didn't really run into applications which don't. Testing random benchmarks and all that kind of stuff. So if you have a driver and you actually want to implement OpenCL or add support for that, what do you actually have to do? So first you have the Rusticl target, where you just have to add your driver the same as you do with OpenGL as well. You have to support OpenGL compute. And you also have to expose supporting near. I think at the moment it's still optional, and you can just expose TGSI and something will convert it to between near and TGSI, but I don't do this in Rusticl. So at the moment you have to use near. There are also a few pipe caps, compute caps you have to expose, but it's just information for the API. How big is your address space and how much global memory you are actually supporting. The subgroup stuff is just for now a workaround, but it's also easy to expose. The actual bigger API which needs to be implemented is set global binding, and it's essentially the front end gives you a list of pipe resources, and the front end needs the real GPU pointer to this resource. And if you actually want to expose the full profile of OpenCL, you have to support 128 textures and 64 images. Most drivers are, I think, at 32 textures and sometimes 32 images or 16 images. And I suspect this is probably the biggest part a driver needs to change besides the compiler. I think DNSI is still at 32 textures and 16 images, and I didn't look into how complicated or painful it would be to change. The last thing which at the moment no driver implements, and I am thinking about requiring for enabling OpenCL by default, it's having real function calls in the backend compilers. No driver is doing it. I suspect it's the easiest to implement in DNSI with their LLVM conversion thing going on. But this has a lot of implication because now backend compilers actually have to think about function calling ABIs. And the main reason I need this is that some OpenCL benchmarks actually produce shaders with like millions of SSA values, and which is the allocation never finishes. So, yeah. On top of that, you also have to support load global and store global, which is just, you have a VM address and you load and store. I also have to rethink on how to do resource mapping. At the moment, that's my current plan, and I'm trying to do unsynchronized and coherent or directly mapped maps, depending on the memory architecture of the driver. The main reason of using unsynchronized is that OpenCL has the so-called non-blocking maps, which guarantee you return a pointer immediately, but the actual data synchronization to this pointer can happen at any time in the future. So this doesn't really map that well with the Gallium pipe transfer API, and that's more or less my workaround to make it work correctly. Then I have another merge request which tries to reduce the overhead of launching kernels, and what it actually requires to, well, it's still optional, but drivers are supposed to implement shareable shaders. And the reason for that is that I want to create the compute state object as soon as possible, so I don't have to do it when launching kernels. Another change is that at the moment we have this load kernel input intrinsic in here to say, okay, we have this OpenCL kernel input buffer, and I'm actually moving this to the constant buffer 0. And if you enable lower uniforms to UBOs, you get it basically for free, so you don't have to do anything. I'm also working on splitting up how we declare shared memory requirements to the drivers. OpenCL actually allows you to allocate more shared memory than what you're using in the kernel directly. So you can say, okay, I have this kernel input, and I say, okay, I need 200 bytes of shared memory on top of what the compiler is knowing of, which works for most drivers, but I think Arduino has a few issues with that. So this still needs to be figured out. So now talking about bindings and what's the problematic bits with that. The current tooling in Rust to generate bindings for C doesn't support static inline. So we have tons of static inlines and I can't use them. So that's really problematic. What I'm doing currently for actually using it for the functions I need them, I have a wrapper library, which is just having a C file with calling those static inlines and just providing them in a hack array. There's, I think, also a pull request on bindgen to actually support it, so maybe it gets fixed automatically. Another thing which I notice a lot is that we use the unsigned type a lot, even if we just want to accept an enum or stuff like this. This actually, for C it doesn't matter because the compiler doesn't care. But Rust C usually says, okay, you can't assign an integer to an enum. So some of this should be fixed up, and I hope that at least for new code that we are stop using unsigned and just the enum type if it's an enum. Bitfield's enums are a little bit special because I think for MSVC we actually have to use unsigned because of some sign bit, and it doesn't match that well. The bindgen can work around this, but it's not as nice as I hoped for. Another problem from the OpenCL header files is that they actually they have forward declared types, and that's a feature Rust just doesn't have. So you have to kind of provide the types yourself and mix kind of your implementation with whatever bindings generation you want to do. So there are still also a few issues with the Gallium API. A lot of the resource handling still thinks in 32-bit limits, which basically means that for OpenCL I have to limit memory allocation to 31 bits. So you can't allocate more memory than 2 gigabytes. which might still be okay, but I also have GPUs at home which have more video RAM than my system has system memory, so it might become a problem in the future, and I don't have a good answer, except just widen the fields and hope that the performance impact isn't too high for OpenGL. Pipe transfers are also a little bit of an issue because normally what you want to do in Rust is you have your drop implementation for when the value gets out of scope and resources are fed. But because OpenCL is a little bit special, you can actually unmap pointers from any context. So I can't have, say, okay, I have this pipe transfer and it will be fed with this context. So this is kind of a thing where I actually have to free resources explicitly, and that's something you usually don't want to do in Rust. The OpenCL's memory API is also a little bit confusing and hard to get actually correct because there are synchronization requirements, and the non-blocking memory mapping stuff goes is a little bit problematic. IDE integration is weird because you don't have this one IDE which supports Mesa, supports C, and supports Rust. So usually what you currently would have to do is, if you are trying to work with Visual Studio Code, you also have to make sure that everything is set up correctly, so include paths and compiler flags and everything is configured correctly. And at the moment, I don't know if this usually works with C code and Mesa out of the box or not, but I don't think so. So what's the thing I still have to work on? It's the one reduction of the kernel launch overhead thing. Then there's also this CL get kernel work group info API, which essentially says, okay, for a given kernel, how much shared memory do I have and how many threads I can actually launch? Because compared to OpenGL or other APIs in OpenCL, you can actually configure the local size of the compute grid. And for some drivers, it actually matters how many registers the compiled binary is using. So that's also one motivation of wanting to create the CSE compute state object in advance, so I can add an API and say, okay, how many threads does the driver support with the given compute state object? I did not do any performance analysis currently, so I don't know if there are many places to improve utilization of this GPU. I just noticed that there are some, when running the OpenCL CTS, there are a lot of CPU limited use patterns, and I have some ideas on how to improve that, but didn't get to it yet. Another thing is I emit a lot of fences, and when I was running some basic demos on Radeon SI, I was like at 40,000 fences per second, which people told me is probably is a little bit high. So I have to think about how to reduce this. There's also a lot of API validation I don't currently implement. So if somebody wants to help out, I usually leave the comments around in the API implementations, and somebody can just say, oh yeah, this error code isn't implemented yet. So that should be fairly easy to do. I don't implement many OpenCL like optional features or extensions. So if somebody wants to work on that, that would also be great. As I mentioned, function calling, this is something we really have to figure out and make OpenCL just work. Which I hope we will get there, but I still think it's quite some work. And I was also thinking about supporting Rusticl, but at the moment there are some bugs in the, well, I wouldn't call them bugs, but the OpenCL specification was more detailed, and what they are doing doesn't really match anymore. And I'm hesitant to work around that inside Mesa, so let's see. So, any questions?
So at Linux Homeless Conference 3 weeks ago, I had a chat with Josh Triplett, who's one of the best people about some of the stuff we've been running into, particularly about like inline functions and some of those binding issues. And it sounds like they are either in progress to solve them and just need somebody to give them some motivation, or willing to look into it. We just need to open the communication channels. But they have a regular meeting where they have people who are using Rust show up and complain and get help. So we might want to show up to that at some point. But it sounds like they're willing to work with us on everything except the Mesa. But I think we already do that.
Yeah, so Jason was commenting on the Linux Panberg conference, Rust people having also some of the same issues I was, especially the static inline stuff. That's my workaround. In the header, I have more header magic stuff going on, but that's essentially how it looks like. It's just, it's a performance impact, and it's just code you have to type, but it's, it's workable. But also people are working on it. I think Bindgen has a PR for that. So it would be nice if this would just work out of the box, but I don't know what the solution should look like, and people also weren't really convinced what they want to do. So.
A little less of a question, but I was wanting to point out this. There actually is a way to
So the question was, why isn't Zinc on a list of supported drivers? Yeah, so the issue with Zinc is, so with OpenGL, you usually can say, okay, I have this renderer node, and I try to search a driver for that, and Zinc says, like for Zinc, you just use a different function. That's fine. For OpenCL, you can't do this. So what OpenCL expects you to do is you check every device on the system, you check what driver, like, do you have a driver for that, and expose a list of all the devices. There are currently not the right interfaces in the pipe loader to do what I need for Zinc. I don't think it's a lot of work. I just looked into it today, so maybe I get it work.
It is work in progress.
Yes, Zinc is work in progress.
I'm a little scared to ask the question, but what's the future of Clover look like then? Are we keeping an entry? Are we making it just LLVM? Are we freezing it where it is? Should I be deleting my no serialized path for us? Because I would love to delete it. Please, you know what? I don't even care what you're saying. I'm getting back to it. All right, Daniel.
Yeah, I will still a little bit say on what Alyssa said, and it was about the future on Clover. I think the big issue with Clover is mostly motivation, because I'm not motivated to work on that, and I'm emotionally exhausted of all the discussions I had. I don't know if others would be willing to work on that. The code is still there. If nobody cares, then we can also just delete it at some point. It's an open question.
This is regarding Zing and also just requiring the compute capability from volume drivers. Aren't you running into precision issues? I mean, OpenCL requires usually a lot higher precision than Mesa. If you just require any OpenGL compute, then that wouldn't really suffice the OpenCL requirements, I think.
I don't think you want to know the answer to this question. There is answer to this question. I don't think you want to know it.
No, it's not. No. So the question is, aren't I running into precision errors precision issues implementing OpenCL? And the answer is I don't. There's this libclc library inside LLVM which actually implements all the OpenCL built-ins, and it's doing it in a correct way. So you have all the crazy functions with their crazy lookup tables and everything. So this is just near code in the end, and we just link against it.
On top of that, sorry for people on the page, but to a certain extent, we're just kind of YOLOing it right now. We're running with CLC when we decide we have to, and the rest of the time we're just hoping that the backend implements it in a way that gives us the precision that we need. Long term, if we want to support compute for real, there's going to need to be some effort put into Node to tag instructions or add new instructions or something to be able to actually guarantee precision. But today we're calling into the CLC and the CTS is passing on Iris, so good enough.
Yeah.
So Rust is taking over clients and so on. And how easy it was for you to find people to review your code?
Okay, so 2 comments. Is Rust taking over the world, and how did I find people to review my code? First, answer to the first questions, it appears to do exactly that, but the future will tell. And for the second, I didn't really find many people. There were some people who are just having more experience with Rust, and they were looking at the code and pointing out things I shouldn't do or things I should do. So it's more like people were just, giving random comments, and this was very helpful. And I hope that more people will do this. So.
Maybe more of a question to some of the ACO people. When can we see OpenCL on ACO?
Okay, so the question is, when can we see OpenCL in ACO? I can't answer this, but what I can say is that for fixing Radeon SI, I have like 10 patches. It's not a lot of work.
Next year.
So next year, okay.
About Node versus Rust. How much is missing from this to write a backend compiler in Rust?
Okay, the question is about near and Rust, and I had code to write near passes in Rust, but Jason didn't like it. Yeah, so it's feasible. I actually have a little bit of code parsing near variables, so I had to have a custom iterator to, that I actually get the information out of the near I need. I think before you can actually write a backend compiler, you have to solve the static inline problem, because near is basically static inline. So I guess it's more like you will have to file the bindings all the time.
Eric is pointing out that this is all solved in my Node 2.0 branch that Michael was going through yesterday.
Okay.
More seriously though, my problem with Karol's patches was not so much talking to Node as trying to modify Node from Rust. It's just not. Like, doubly linked lists and Rust are not particularly.
I'm not talking about Node by Rust.
I'm just talking about. If you want to treat it read-only and write a backend, there's no reason why you couldn't approach from all the static inlines. That's the big painful point. And we have the iterator macros, but again, we can make Rust versions of those if the goal is just to be able to iterate. The big problem is the actual static inlines, and that's solvable with either lots of typing or some hijack fixes.
Yeah. So if you want to use Rust into your Rust for your backend compiler, you can just write all this near passes in C and just consume it in Rust code. That shouldn't be a problem. I mean, I'm doing the same in Rusticl. So.
right now, Rusticl has very little surface area for that binding, so it's all good. I'm not excited about having an entire backend compiler worth of binding, given how many breaking changes we make to nerd, and then how much of that we are currently doing with, SED and maybe OpenCL if you're lucky that one time. So if somebody really wanted to do it and really wanted to take it on, I'm not going to say no. Also, if they try it, a nerd style compiler in Rust, and it just I hate C, but the language I write compilers in is C. It's C plus a god-awful preprocessor plus logic and plus Python, and that's a first language, but it works pretty well. I don't know. So, big shrug.
I will paraphrase what Alyssa just said is essentially it's a maintenance issue. If you want to use more Rust inside Mesa, you also have to think about everybody else will have to deal with this. So the good thing about OpenCL is the surface area in Gallium is very low. And I'm not touching the interfaces Marek is optimizing. So that's a huge benefit. If we start to do more Rust stuff with Near, then Near people will complain at some point if it's getting too much too fast. So we have to be careful and a little bit slower with that, I think.
Extra amounts of textures and images provided by drive would actually be somewhat performance sensitive, and that is data has to be kept track of for high profile applications too. Have you considered digest textures for getting more images for the profile?
The question is about driver overhead supporting more textures and images, and if I have considered supporting bindless images and textures. I didn't. I suspect we could do it all bindless. It just means we have to pipe through the address to the kernel, which I currently don't do. I think it would be painful to support both paths. So maybe I just try it out and see how it goes, but.
We also not like to see bindless support in Geo drivers of Intel can do it, it hasn't been done yet, but the mobile pods aren't going to start supporting Geo bindless. So it's pretty limited. And if you do your handling properly, it should scale based on the number of total possible textures, which should mostly scale based on the number you have bound and we're using. So
yeah.
it is not a big problem.
So one issue is that OpenCL supports more hardware than is supported by bindless images and textures. Like there are even drivers not supporting GL Compute, which can do OpenCL. So.
Whatever it's worth, I don't support mindless net for us. The hardware to do it, NDK will do it eventually, I assume, but I really don't want to support it and using it.
Yeah. Yeah, so Alicia was saying that supporting it in Panforce comes with a performance penalty. And I think, most drivers will just support OpenGL and deal with bindless later. So that's just a higher bar for actually supporting OpenCL side. Yeah. Okay.